Assalamu alaikum guys. Today we are going to start another new chapter under Unit 2. Valency shell electron pair repulsion theory. Simply you can call as what that is as a VSEPR theory. I am Najmunisha Ashar. Today I am going to explain you how this VSEPR theory may impact on your structure and bonding. Let's move on to the contents. So first we have to understand what is meant by the VSEPR theory. Why we are using the VSEPR theory, right? Earlier we have studied about the Lewis structure. By using Lewis structure, I am going to keep the step on the VSEPR theory. Next, what is called the repulsive unit? Yes, in order to understand the VSEPR unit, right, VSEPR theory, we have to know about the repulsive unit. Finally, the VSEPR theory is very important for your final examination. I am going to introduce some of the example how to determine how to find the VSEPR unit according to the repulsive unit. Let's move on to the subject now. Yes. Earlier we have studied what is meant by Lewis structure. Why we step into the Lewis structure. From the Lewis structure only, this VSEPR theory arrived. Right. So what they are saying is the Ronald Gillespie and the Ronald Sidney Nilo suggested that electron pairs surrounding the central atoms of a given molecule or ion are arranged in a way to keep maximum spatial distance apart from each other. So they simply said, right, when you think about what? A molecule or structure, right? So it might have the bond and the lone pair, both are there, right? So what they are telling is, though it should be a molecule or an ion, right? They are telling is the electron pairs surrounding the central atoms, right? Around your given molecule or ion, how it's arranged, they have the maximum spatial distance to maintain the to maintain arrangement, right, apart from each other. Why they are having the maximum distance? So this is what we are going to study in the VSEPR theory, right? And the Gillespie has explained the shapes of the molecules when the central atom is a main group element, while Nylon discussed the shapes of the molecule with the transition elements as the central atom. So they have two ideas, right? While the Gillespie said, right, the Ronald Gillespie said, this is what the shape of the molecule is there according to the central atom, right? And also the nylon, he incorporated and he said, right, the shapes of the molecule with the transition element as the central atom. Two things they said. Finally, what they said, yes, by 1963, the Gillespie introduced VSEPR theory for finding shape of the molecules of iron. They have something other conflicts, right? The Ronald Gillespie and the Sidney Nilo, right? They have found the electron pairs around the central atom. They have the maximum spatial distance apart from each other, right? So according to that, Gillespie has said the shape of the molecule when atom is a main group element, while the nylon incorporate, he said the shapes of the molecule with the transition element as a central atom. Then finally they concluded, yes, the Gillespie introduced, yes, that is called valency shell electron pair repulsion theory. That is you can simply call it a VSEPR theory for finding the shape of the molecules of iron. I said, why we need the VSEPR theory? That is the major reason we need to find the shape of the molecules and the iron. So there are mainly two kinds of the electron pairs surround the central atom. You should be very careful about that. I earlier mentioned, right? When you take a central atom, you might have the two types of the central, right, electron pairs. How should be? Yes. The first one is bonding electron pair which is held between two nuclei by attractive forces. So one is the bonding electron pair. What should be the another one? That should be the, yes, electron pair not participating the bonding pair, the bonding. This is what we are calling as lone pair. So when you take, okay, as an example, just look at your answer. Just write it down. Yes. So simply think A and B making a bond, right? You see A and B having a double bond. A having the lone pair, right? B doesn't have any pair. Okay. So you're going to talk about what? The VSEPR theory. I just come to right? So who is the bonding pair? Who is the lone pair? Yes, you should be very able to find it, right? So this is what bonding pair, bonding electron pair. So this is what he said. Yes, it's attractive. Two nuclei in between the two nuclei held because of the attractive forces. This is called the bonding electron pair, and this is what we are calling the lone pair. Hereafter, I will mention as a lone pair. You should be able to understand, right? So that these electron pair not participating any bonding. So this is what we are feeling is lone pair, right? Okay, let's move on. Just give me a second. So both bonding and lone pair of electrons of an atom act as the repulsive to keep further away from each other. I said around the atom what are the bond types, electron pairs are present. So one should be able to make the bond, another one should not participating in the bonding. So that should be the lone pair. These two, bonding and the lone pairs of the electron of an atom, act as what is your repulsive unit. These two types of the electron pairs known as the repulsive unit to keep further away from each other. So you should be able to find. How can you calculate the repulsive pair? Yes, should very much noticed, right? If multiple bonds, yeah, what is mean by the multiple bond? It could be double or triple bond are present between atoms. Each multiple bond is considered as single repulsive group. Did you understand what they are telling us? Right. When you take, right, any bond, right, if you take any bond, it is able to produce, right? Okay, we'll say A between B should be the single bond. A between B can be the double bond. A between B triple bond. So this is a single bond, double bond, triple bond. So though it's a double and triple, we are telling it is as a multiple bond, right? So either double, multiple bond or single bond. You can say if it is a single or double or triple, these all are considered as single repulsive unit. So if it is A having the double bond or single bond, we are telling repulsive unit is 1. If it is having the double bond, that is also the repulsive unit is 1. If it is having the triple bond, we are also repulsive unit is 1. You should be very careful about that. Right? Okay? So each single double bond or lone pair is considered as one repulsive unit or VSEPR. So what is mean by the VSEPR unit or repulsive unit? Either it could be what the single repulsive unit, what is that? It's a single bond, double bond, triple bond, and the lone pair, right? So those are considered as a single one repulsive unit of the VSEPR unit. So let's define some example. Then you will understand how I can choose. Take this HCl. This is what your molecule structure of the HCl, the Lewis structure. You should be able to do it, right? Okay. So look at here. What is it? The three pairs of electrons in the triple bond of HCl. Okay. Without going the notes, let's find the repulsive unit here, right? So I am going to find the repulsive unit around your carbon atom, right? Okay. What is the repulsive unit for carbon or VSEPR unit for carbon? Here. Look at your carbon, right? Let's we have the number carbon. Okay. The carbon having what? Your right side is a triple bond and the left side is a single bond. Therefore, the VSEPR unit is 1, 2. You can say the carbon having one single bond plus one triple bond, right? You will end up with what? The repulsive unit is 2. What about the nitrogen? So the repulsive unit of the nitrogen. Okay, again we'll have the another color. Yes, look at very clearly, right? Nitrogen. So here the triple bond is 1 and you have the lone pair that is 6. So you have one triple bond plus one lone pair. Not number of electrons, should be the pair of electrons. So one lone pair. So nitrogen also having the 2 repulsive units. Or you can say the VSEPR. Are you all clear? Right. Okay. Again, I'm just recalling, right? Look at here, carbon having the one single bond and another triple bond. So, though it's a single, double or triple, we are telling that is one VSEPR unit or repulsive unit. Therefore, your carbon having what? The 2 repulsive units. As well as check your nitrogen. Nitrogen having one triple bond as well as the one pair of right lone. You can say the lone pair, not number of electrons, that should be the pair of electrons, right? Again, you can say what? Here it is having the 2 VSEPR units. You should be able to understand, right? Thank you. So, look at the 3 pairs of electron in the triple bond of HCl molecule is considered as a single repulsive unit. I say right. This is because the 3 electron pairs are located between the carbon and nitrogen, preventing the independent movement of 3 electron pairs from each other. Thus, the triple bond can be considered as a single repulsive unit or single VSEPR unit. Why we are considering, even though it is a triple bond, as a one VSEPR unit or one single single repulsive unit? What is the reason? Yes, those we have between the carbon and nitrogen, you have what? 3 pair of electrons, right? Which is the preventing independent movement of the 3 electron pair of each other. So that's why it's considered as a single repulsive electron. The number of repulsive units surrounding the central atom can be clearly identified by using the Lewis structure. That's why we studied what is meant by the Lewis structure. If you draw the Lewis structure in correct manner, then not only you can find what Yes, what is your VSEPR units? How much is considered, right? So Lewis structure is a basic and very important stuff for the VSEPR unit. The following example explains how to identify the number of electron pairs surrounding the central atom and the VSEPR units around the central atom. Right? Okay, so let's we move on to the example one by one. So let's we move on to the example one by one. The first example. So I have given the tabulation. You just have a look, right? The first I'm going to give the molecule. The second, it's very important. In order to find the repulsive unit or the VSEPR unit, you have to draw the Lewis dot structure. And I'm going to find how many electron pairs around the central atom. What? Your lone pair plus bonding pair, right? Finally, you can find what is the value for the repulsion unit or the VSEPR unit around the central atom. So the what should be the first example? Sulfur dioxide, SO2. So let me draw the Lewis dot dash structure, right? So yes. So the Lewis structure we have studied in your previous presentation. This is what the Lewis structure of the sulfur dioxide. You can see here very clearly. The sulfur is having what? One lone pair and two double bonds. The oxygen also having what? Yes, the two lone pair and one double bond, right? Likewise, your two oxygens are there. So the electron pairs around the central atom, I am talking about the central atom, not the oxygen. So you have to select the sulfur to find the electron pairs around the central atom. What should be the value? Any idea? Right, I'll give the answer. What is the answer? Yes, that is 5. How this answer came? Yes, anyone? Any idea? Yes. So hopefully you might guess. I will use a color and let you know. So look at here. I'm talking about the electron pair around the central atom. When you take the central atom, you can see, here you have the one lone pair. So electron pairs around the central atom, there should be one lone pair. When you take the sulfur, you have the two double bonds, right? So the double bond consists what? Yes, your double bond having what? Yes. Two electrons, two pair of electrons, right? If you say like that, you have the two double bond. So two double bond is equal to 2 into 2, 4 electron pair, right? So ultimately, one lone pair plus 4 electron pairs, right, bonding pairs, you will end up with 5. Now, can you say what should be the repulsive unit? Yes, what should be the repulsive unit? So look at your sulfur. You have one lone pair, right? And you have the two double bond, right? Two double bond, or you can say two bonding pair. So 1 plus 2, your repulsion unit is 3. Let's we see. We found the answer, right? Okay, are you all clear? So let's we move on to the next example. It should be little more clear. So next molecule is sulfur trioxide, SO3. Now you should be able to draw what? The Lewis dot gas structure. Let's find the electron pairs around the central atom. Right, I will use the annotation. Now I'm just going to count it one by one. Right, here you have 1, 2, 3 double bond. Each double bond containing the 2 pairs of electrons. So 3 into 2 pair of electrons. So what is the electron pairs around the central atom? Yes, that is 6. So let's check. Is it a 6 or not? Yes. And what should be the repulsive unit? Yes. Again, I am going to find about the repulsive unit. Though it is yes, single or double or triple, right? It's considered as a 1 repulsion unit. So here you have 1, 2, 3. Your answer should be 3. Let's check. We found the answer, right? And let's move on to the next example. Okay. Hydrogen cyanide, xenon. So we know the structure already. Yes, the carbon containing one is a triple bond and another one a single one. I already told you. So what is the electron pairs around the central atom? When you take the central atom, what should be the electron pair? Yes, the carbon is containing one triple bond. The triple bond means what? 2 into 3. Sorry. 2 electron into 3 bond. That means 6 pair of. Right. Take one bond. So altogether you have 8 electrons. 2, 4, 6. Right. And this is one altogether 8. Let's see if we are all drawing. Okay, I have found what the number of electron. Now you should able to write what is the number of pair of electron, that is 4. Yes, here you have the 2 electrons, the 2, 4, 6, 8. That means what? Now you have the 4 pair of electrons. Are you all clear? I just you confused, okay, confused about what? What is mean by the pair of electron? What should be the, yes, the number of electrons. I just said about the number of electrons, right? So when your one thing is you should able to find the number of electrons. Each one bond contribute the 2 electrons, right? So here we are talking about the electron pairs around the central atom. So you should able to find, yes, the 2 electrons contribute the one bond. That is what we are telling is the electron pairs, right? The pairs means what? The 2 electron equals to 1 pair of it, right? So this is called 4. So let's find the repulsion unit. Yes, again we know the value. We already found it. Yes, when you take the carbon, right? The carbon having one single or triple bond, another single bond. Yes, because of one triple bond, it's having the 1 VSEPR unit, and one single bond having another VSEPR unit. So your answer is 2. So let's check. Yes. Let's move on to the next example. So the next example 4 is, the molecule is SOCl2. So until now we just studied about what the different structure. So now you have another sulfur having what? 2 Cl group and the 1 oxygen group. Let's say about the electron pairs around the central atom, right? Okay. So here you know You have the one lone pair means what? One pair of lone pair. One pair of lone pair. Right? Okay. And you have what? Two single pair. Right? So, two pair of single bond. Right? And go for what? You have the two oxygen, right? So the oxygen having the double bond. Okay, again you have the two pair of. So let's say the one double bond. So the one double bond means what? You have the two pair of electrons, right? So now 1 plus 2 plus 1. Sorry, 2. So altogether it should be 5. Let me check. Is it a 5 or not? Right, that is a 5. Now again I'm just going to speak about what is the repulsion unit around your central atom. Yes, you have one lone pair and you have, yes, two single bond and you have one single bond. One double bond. Okay, so now you can say all together 1, 2, 3, 4, 4 repulsion units. Let's be check. So yeah. Finally, we will go for the final example, right? That is the molecule NO2 plus, right? You have now I'm here speaking about the iron. Again, you should be able to do what? The Lewis structure. Now you have the positive ion on what? The nitrogen. So let's check the electron pair around the center atom. We are not thinking about your positive charge, but here you are having what? Yes, two double bond. Therefore, what should be your electron pairs around the central atom? That is 4, right? And what should be the repulsion units around the central atom? Again, you can see here 1 and 2 double bond. Therefore, even though that is a double bond, we are considered as a 1 repulsion unit. Therefore, you have here is 2 repulsion units, right? So most of the probability we have spoke about what that is. What is meant by the VSEPR unit? How is showing the impact on the structure and the bonding? We have to find the shape of the molecule. For that sake, we should know the VSEPR unit. So it is what is meant by the repulsive unit, right? The lone pair and the bonding pair around the central atom, right? And when you speak about the repulsive unit, though it is having, yes, single or double or triple, it's considered as a 1 repulsive unit, and each lone pair also considered as another repulsive unit. According to that, we have done 5 examples to determine the VSEPR unit around the center atom, right? Anyhow, thank you very much, guys. I have done what is mean by the VSEPR unit, and the next your presentation based on what? By keeping this VSEPR unit, how I'm going to speak about the geometry of the molecule. Once you understand the geometry of molecule, then we are going to speak about the each different geometry having the each different shapes. How the shapes are. Even though VSEPR unit is common, the shapes are different. according to the presence of the bonding pair and lone pair. We are going to speak about that later. Anyhow, we will see you later. Until that, guys, see you. Bye bye. This is Najim Shah. Assalamu alaikum warahmatullahi wabarakatuh.